End behavior. Okay, we had a question on end behavior. Okay, how do you do it? Well, basically, it's very simple. You assume x to be a really big positive number, then a really big negative number, and see what you get. Okay? So, example. X minus 3 over x plus 7. So 1 equals. Okay. If x is a really big positive number, then what can you say about x minus 3? It'll be positive or negative?
Positive.
Yeah. Okay. X is a really big positive number. X minus 3 is going to be a really big positive number. But what percent do you think x minus 3 would differ from x? Well, you make that percent as little as you want by making x as big as you want. Okay? But what percent does x minus 3 differ from 1,000? Well, 0.3%. 3 parts in 1,000. Very little difference. Okay, so if x is this big, x minus 1,000 is also, well, get my hands on them. If x is this big, x minus 1,000 is also this big. I can't even think how I would move my fingers, my hands, a minute enough distance to represent x minus, to represent the 3. How big, if this is 1,000, how big is 3? Yeah, my hands are vibrating more than that. Okay? Yeah, my heart's beating, I think. And, you know, all kinds of other things are going on, okay? It's not totally steady. It's those little vibrations are bigger than 3 out of 1,000. And if x is 1,000,000, well, they're 1,000 times smaller. Okay, 3 is 1,000 times smaller compared to 1,000,000, right? So x minus 3 for a big number is as close to x as you want it to be, in the sense of a percent difference, okay? And x plus 7 is as close to x as you want to be. Okay, so large x okay? And it doesn't matter whether x is positive or negative in this case. It often does, but not in this case. So the far right and far left values approach 1. Okay? And I can sketch a quick graph of this. You're going to have an asymptote at x equals 3, vertical asymptote, and another one at x equals -7. And let's say that this is a line y equals 1. So you have a vertical asymptote here and a vertical asymptote here. Well, y is approaching 1 on this side of 3, and it can't change from positive to negative except crossing a 0 or an asymptote. Okay? So it's got to be positive, and this is an asymptote, so it has to do this. Over here, same thing, it's positive. It's going to be a little hard to draw because it'll go right through my words, but it's going to do this. And then in between here, you see that if x is 0, you get -3/7. So your y-intercept is negative. it's got to be negative for this whole interval between -7 and 3. So you're going to have a graph is this sort of thing. So that's a little more, but that's how the end behavior fits into the graph. Okay? Now, y equals 2x plus 7 over -5x minus 2. Do this kind of quickly. Okay? Plus 7 and the minus 2 don't amount to hill of beans if x is big. The only thing that matters is the highest power term you have here. Well, now you get -2/5. Okay? Whether x is positive or negative. You got this one? Okay? Large x. This thing's practically equal to x times x over x. So for large positive x, y approaches plus infinity. Bigger x gets, bigger y gets, right? And for large negative x, y approaches negative infinity. Okay? It's going to, this is going to have the same sign that x does for large x. Okay. Also, if I want to do this graph, excuse me, the graph goes through -3, 0, 4, 0, and has an asymptote at -6. Okay, so the other thing is that the graph approaches y equals x. We just figured that out. It came right out of considering the end behavior. Y approaches x. So I can draw the line y equals x. It's supposed to be a straight line. Tray here. Okay. So you got the straight line where y equals x, meaning that the further you get out to the right, the closer the graph is going to be to this line. And the further you get out here, the closer it's going to be to this line, to the line on this side. You know it's going to be positive to the right of x equals 4 because it's approaching positive value. Value can't change here. So whatever happens at 4, the graph is going to go through here, and it's going to approach this straight line as an asymptote. Now if you do the signs and everything, and I'm not going to go through all that, you're also going to approach the line as an asymptote. Here, you're going to go through this, and you're going to approach the line. It's going to be positive here, it's going to be negative here. Of course, you got to figure that out. But you know the y-intercept is -2 if you just plug in x equals 0. So the graph would look something like this. One more example. Okay. And this is a little more subtle. For large x, well, if you square a large number, it's going to be a lot bigger than the number itself, right? If you square 100, you get 10,000, okay? So this number is going to be itself times this number. So unless you got a number like 10,000 in front of x, all I got to do is, if you want to use, x equals 100, you could. Okay, no matter what number's in front of this x, you can make x big enough that x squared is way, way bigger than that number times x. Just make that number way bigger than whatever's in front of x, and it's going to happen. So the idea is then that for large x, y is going to be close to x squared times x over x, which is x squared. Okay? Positive. A large positive or a large negative x. So for large x, x goes to plus infinity. Your graph of this function would have an asymptote at -1, vertical asymptote at -1, a 0 at x equals 2, and you know what x squared does, the bigger x gets, the steeper it gets, right? So you just check out your signs and so forth, and also your y-intercept, which in this case would be -12, be down here, and I'm not going to label it. So you've got to come down here from very large positive values, and then maybe through here. It'll look a lot like that. Uh-oh, that was really dumb. This is an asymptote. Sorry, I'm a little off today. You're used to that, I know. Don't feel terrible, but what's got my sinuses pressing in the part of my brain that does things right. Okay. No excuses this time. Okay, so you got -1 here. you've got 2 here, and you've got a vertical asymptote here. Okay? Yeah, positive on this side of the asymptote, positive over here. So, it comes down here, large positive values, comes down steeply, but then it approaches the asymptote on this side. And then, does something that makes no sense at all. Negative here. It should change sign. It actually is 1. Of course it does. Okay. Let's see if I can think of another excuse. That doesn't work. Because on this side, it's negative, so it'd have to come up from here, go through here, and up through here. And x equals -1. X plus 1 changes its value from negative to positive, which is going to change the sign of the whole thing, so it can't be on the same, can't approach this asymptote in the same way. So now if I think clearly about what I'm doing, I see that I should have gone ahead and said, okay, it's got to be positive over here, it's got to be positive over here, and it's got to be negative in here. It's negative in here because it's negative here. It's positive to the left of here because it's positive at both ends. It's positive to the right of here because it's positive, because I do have a plus sign there, but it didn't come out. Okay? So what it's got to do is it's got to come down from here. It's got to turn around before it hits 0 so it can go up along this asymptote. Then you come up from this negative asymptote through this point, through the 0 to 2, and on up. Okay? So apologies for the misfires there, but that's it. Okay? And if you misfire like I did, and of course I was only pretending, if you misfire like I did, something's not going to work. Something's going to contradict itself. So every time I misfired, something contradicted something, right? It couldn't do this, it couldn't do that. And the more insight you have into the way these things work, better off you'll be, okay? But follow the procedure. The procedure I've given you for rational functions is you divide up the x-axis into intervals, determine where the function's positive, where it's negative. Look at the end behavior. X gets huge. Well, that was the main question here, right? And then you put it all together. Okay? And you also want to do the y-intercepts. That's usually pretty easy. Just plug in x equals 0 and take the numbers you got and multiply, divide. Okay?